Hey folks, welcome to Breaking Ground. I hope you guys had a nice lunch and are not too sleepy because we're doing 6 degrees of domain admin. We're going to learn about Active Directory privilege escalation, so I'm pretty excited. Before we begin, I'd like to thank our sponsors really quickly. B-Sides is sponsored this time by Versprite, Protivity, Amazon, Tenable, and Source of Knowledge. They all are hanging out in our chill out lounge, so go say hi, get some cool swag. If you could please turn off your cell phones or turn them on silent and be respectful, that would be nice. And that's all I have for you. So I'll hand it over to the speakers, let them introduce themselves, and take it away.
Thank you. All right, welcome everybody. The title of our talk is 6 Degrees of Domain Admin. If you're not familiar with what this reference is, there's this thing called 6 Degrees of Kevin Bacon, where you can take any actor, any movie, and in 6 degrees of separation, you can more than likely connect that person or movie or director or whoever to Kevin Bacon. So we've taken that same concept and we've applied it to Active Directory privilege escalation, and we're super excited to talk about it. So let's go to the next slide. My name is Andy Robbins. I've been a professional penetration tester for 4 years. I originally cut my teeth in the financial services industry, focusing on community and regional size credit unions and banks. If you're interested in talking about ACH files, I would love to talk about those with you. Otherwise, you can find me on Twitter at _Waldo with a 0 at the end.
Hi, I'm Rohan Berserker. I'm one of the penetration testers at Veris. I've been doing penetration testing for about 2.5 years now. I contribute to a bunch of open source projects, namely Eyewitness and Empire. Other than that, I'm just a web dev, so.
He's way more than that. So, hi, my name is Will Schrader. My handle is Harmjoy. I'm one of the big kind of offensive developers in our team, and I also do offensive red team pen testing type engagements. I'm the co-founder, lead developer, or one of the main developers on the Veil framework, PowerView, PowerUp, Empire, all that kind of fun stuff. So, yeah, take it away.
Cool. All right, so first we're going to talk about kind of what the current state of Active Directory domain privilege escalation is. So by a show of hands, can I ask anybody who is involved in AD security at all, either on offense or defense? Cool, so most of the room, awesome. So you should be pretty familiar with the concepts that we're going to be talking about. So let's go ahead and go to the next slide. So if you're involved in Active Directory security, you have more than likely seen this quote. It's probably one of the most overused quotes in our industry. So John Lambert, the general manager at the Microsoft Threat Intelligence Center, had a blog post with this title. So defenders think in lists, attackers think in graphs. As long as this is true, attackers will win. So what I would ask everybody is just keep this thought in mind during our talk. What I'm hoping that we can show you is that not only are attackers thinking in graphs, but now we're actually going to be using them as well. All right, so Active Directory, as we all know, is effectively ubiquitous across the entire world. If you see Sean Metcalf's talk at DEF CON or Black Hat, one of the points that he brings up is that 98% of the Fortune 500 companies in America use Active Directory. Pretty much a given, right? So what does that ubiquity mean? That ubiquity means that Active Directory gets a lot of attention, both from the defensive perspective and also the offensive perspective. There's a lot of time, research, money, effort, blood, sweat, tears that goes into understanding how best to defend and attack Active Directory environments. So, as penetration testers and as red teamers, what that means is that every so often we get these nice easy buttons that make our jobs super awesome, and we get to look like an elite hacker because we popped a box with MS-08067, or we escalated rights to DA with MS-1468, and like, yes, I am an awesome hacker because I used a certain module to do that, right? So these easy buttons, as awesome as they are also ephemeral. They have a tendency to go away, especially as our client organizations mature certain practices. So their vulnerability management practices get better. They're actually starting to pay attention to some of the things that we've been saying for years. Run vulnerability scanners, do centralized patch management, audit the results of those. What does that mean? That means that you have a certain window of opportunity to use those easy buttons on your assessments unless your client is really not at that stage yet, which is also a lot of fun. So let's go ahead and go to the next slide. So here's a typical situation that you might find yourself when you're on a pen test that you are focusing on Active Directory. So you get your initial foothold into the environment. Maybe this is a interpreter session that you got from phishing. Maybe this is Beacon if you use Cobalt Strike. Maybe you started off with Layer 2 access and you use Responder to get your initial privilege on a machine somewhere in the environment. Now, thanks to some work by Will Schroeder, you can use PowerShell and PowerReview to collect information about the environment that you're in. So all of these like dotted boxes, these are going to represent systems that we know exist in the environment, but we don't have any kind of privilege to yet. Additionally, we can find out where a domain admin user is logged on. You don't need administrative rights to find this information. Who, like by a show of hands, who does this all the time? Like on your assessment, you're using like Invoke User Hunter, you're using Git in a session. You're finding out where the target is in the environment, what box you need to land on, and run mimikatz and steal their credential. All right, now, in this kind of like, maybe a little less mature type environment, let's say you're able to escalate your rights locally on the system. You run hash dump, you collect the NTLM hashes for the local users, including the RID 500 user. And maybe they've applied KB 2871997, the pass the hash killer but not really pass the hash killer patch. Or maybe they haven't. Bottom line is, you escalate rights on this one machine, and then you gain kind of notional administrator privileges to everything in the environment. So did that click work? Okay, there we go. Cool. So the solid blue lines on these computers are going to represent systems that we now have the ability to pivot to. And lo and behold, who should appear but the domain admin on this system that we can pivot to? So we pivot over to that machine, we run mimikatz, we collect that domain admin's password in clear text, and we win. We're awesome, we're pen testers, we're elite hacksaws. We give the report to the client and they think that we're the most amazing person on the planet, right? Who's done an assessment where the escalation path looked almost exactly like that? A lot of you, awesome. So let's take a look at a slightly different environment. So again, we get our initial access through Beacon, Interpreter, Responder, whatever. You got your initial access, and again, you can figure out where the domain admin is logged in on the environment. However, this environment actually does have fairly mature patch management, vulnerability management processes. So you can't find MSO 8067, you can't find Tomcat, you can't find JBoss. KitcherPod has been gone for a decade, right? So let's hit next. Let's say that eventually we do find some kind of privilege. I would say that 9 times out of 10, the way that we on our operations usually get our initial foothold into an environment are clear text credentials that are left over in open file shares. And what I mean by open file shares are shares that any user who is authenticated to Active Directory has the ability to read. So what does that most commonly mean? Like GPP, login scripts, etc. We find this all the time. So let's say in this situation we found that as well. At this point, we need to make a choice. We need to make our best educated guess on what system is the best to pivot to. We see these 3 users in these systems that we can pivot to, but we know that none of them are a domain admin. And we also know that none of them have local administrator rights on that system that the DA was logged on in the first place. So essentially, we have to guess, or you can go through the analysis, which is a royal pain. So let's say we make a choice. We decide we're going to pivot to this guy's box. Next, we find out what systems does this new user that we have the ability to impersonate have access to. And we find out that our scope of administrator privileges in the environment is starting to grow very slowly. Now we need to make another choice. We can either say, all right, well, I have these 2 other boxes in this first stage that I could pivot to, so do I want to go there, or do I want to go to one of these new boxes that I have privilege on? Let's say I choose to go to this one in the top right. I see that maybe there's something in his user account properties that indicates like maybe he has some kind of privilege, like he's a SQL admin, or he's he's a patch management type admin, something like that, a WSUS admin. Now, we pivot to that guy's system. We figure out what admin rights does this new user have in the environment, and we find out there's nothing new. We are still where we were, and so we're going through this kind of credential dance, this kind of credential shuffle, where we have to go to this box, get the password, find out what we have admin rights to, and if we fail like we did just now, we have to go a step back, and it sucks, and you get really upset, and you reset, and you make another guess. And so this time we guess, let's go to this guy over here, and then we find out what admin rights this new user has. So, lo and behold, what should appear, but this new user that we just popped has admin rights on the system where the DA was logged on. Awesome. So what does that give us? That gives us access to the domain admin account, which now we have access to the entire environment. So this kind of like credential shuffle, or what Microsoft refers to as an identity snowball attack, by a show of hands, who has executed an attack path like this? Most of you. Awesome. Sweet. I'm glad you're here. So this concept we refer to as derivative local admin. Our coworker, Justin Warner, termed this phrase after seeing this kind of pattern on our assessments over and over and over and over. The way that Justin describes this is the chaining or linking of administrator rights through compromising other privileged accounts. Makes sense. Good definition. Concise. So put another way, let's say we have this user, Bob. Okay? Now, Bob has admin rights to this computer called PC1. On PC1 is this user named Mary. Mary has admin rights on this system called PC2. So Bob derives administrator privileges to PC2 through compromising Mary as she is logged onto PC1. Another way that this can happen is through security group delegation in Active Directory. So let's say that Bob is a member of a group called Help Desk. Let's say that Help Desk doesn't have any privileges in the environment. However, Help Desk is also a member of this group called Server Admins, which does have privilege in the environment. That delegation, that right, that privilege rolls downhill as you add groups into groups. So Bob is a member of that group is a member of that group has admin rights to PC2, Bob has admin rights to PC2. That makes sense so far? Awesome. All right, so while the derivative local admin attack is highly effective, and I would say that on almost 100% of our engagements, if we get any kind of privilege, give it enough time, we can turn that privilege into domain admin or enterprise admin. There are some significant challenges and weaknesses with this approach as well. First of all, this approach is extremely time-consuming and tedious work. Every step of the way, you're having to reset and gain your new situational awareness. You need to find out, where does this user that I now have access to have privilege? That means that you're going to touch, possibly, every system in the environment again, which if you're on a red team assessment or you're trying to evade detection, is bad news bears. Don't want to do that. We want to hit every system one time and get all the information that we need. So additionally, the information that you're getting when you're executing this attack path is not comprehensive. So the biggest weakness I would say is this right here. So you take your report to your client, you say, here is this attack path. That attack path you really couldn't understand or identify until it was already executed. Additionally, there are probably other attack paths in the environment that unfortunately is just not really possible to know about without some kind of tool like what we are talking about today. Next, you have limited situational awareness during the entire course of your escalation process. Okay. Finally, you may not have even needed domain admin rights in the first place to meet your objective. If your objective was to get access to a SQL server or a web server, it makes sense to go after a DA because that DA is going to have access to what you need. Or they're going to have access to the workstation who has a user on it that has the access that you need. Cool. So we're going to be talking about graph theory briefly. So go back in time, go back to Computer Science 102, If you don't have a CS background, don't worry because neither do I, but this is pretty easy to understand. We're also going to be talking about the design of our attack path. Everybody good so far? Lots of nodding heads. Oh, cool. So what are the basic elements of a graph? First of all, in a graph, you have vertices. Vertices represent an individual element of a represented system. So put another way, let's say that we are building a GPS program, right? Google Maps, fun fact, uses graphs for navigation purposes. Let's say the city of Washington is a vertex. Portland, Oregon may also be a vertex. Walla Walla, Washington could be a vertex. Las Vegas could be a vertex. Next, we have edges. Edges generically represent the relationship that connect these vertices. If Seattle, Washington is a vertex and Portland, Oregon is a vertex, Interstate 5 is the edge that connects those two vertices. Finally, we have paths. Paths are a collection of vertices and edges that connect otherwise disparate or disconnected nodes. So there is not a highway that directly connects Las Vegas to Seattle, Washington, but there is a collection of interstates, state highways, towns that you can go through that will get you from point A to point B. Awesome. Put in a visual context, we have two vertices in this graph. We have vertex 1 and vertex 2. There is also an edge that connects vertex 1 to vertex 2. It is a directed edge, so it is one way only. You cannot go from vertex 2 to vertex 1 against the wrong direction against this edge. You can go from vertex 1 to vertex 2. On this slide, let's talk a little bit about paths. As you can see, and this is fairly simple to look at and understand. Vertex 1 to vertex 4, there is pretty obviously a path. Okay? From vertex 3 to vertex 4, is there a path? There's not, because these edges are one way. Make sense? Cool. So, we have a tool that we are going to be demoing called BloodHound. The design for the BloodHound graph is as follows. The vertices in the BloodHound graph represent the basic objects in Active Directory. Every user, group, computer, and domain is a vertex. The edges represent the relationships between these different vertices, which I'll talk about in more depth on the next slide. Finally, the paths. The paths are the most critical part of BloodHound. The paths always point towards escalating rights, or always towards compromising a system or compromising a user, or a user who's a member of a specified group. So let's take a look at this visually. Like I said, every vertex is an Active Directory object. So we have two users on this graph. We have Bob and Mary. We have two groups, IT admins and domain admins. And we have a computer called Server 1. Next, we determine the group memberships. So we see that Bob is a member of the group called IT admins. We see that Mary is a member of the group called domain admins. Next, we determine privilege. We determine what groups, what users have administrator privileges to what objects. So this group called IT admins has admin rights to this computer called Server 1. Finally, we determine who is logged on where, and we find that Mary is logged on to this computer. So this computer has a session called Mary. Can you see the path from Bob to domain admins? Awesome. So let's put this really simply. First of all the information that we're talking about here, you do not need privilege to gather in Active Directory. Thanks to WinNT providers, API calls, Will is going to go into a little more depth on that. So we need three pieces of information. We need to know what users are logged onto what machines. Again, you can find that without privilege. Secondly, we need to find out who has admin rights where, which you don't need privilege to do. And finally, we need to find out what users belong to what groups and what groups belong to what groups. This is all we need. This is all the information we need to build our graph. I'm going to pass it over to Will.
Cool. All right, so I'm going to go over some stealthy data collection with PowerView. So did anyone read the pastebin dump from Phineas Fisher from the hacking team stuff? We obviously do not condone in any way using our tools for illicit purposes, but thanks Phineas for the publicity, I suppose, for calling out PowerView. So it was a little bit of a surprise seeing all that in there. So what is PowerView? PowerView is a pure PowerShell 2.0 compliant Windows domain and situational awareness tool. It kind of came about from starting to do these more advanced red team engagements and starting to do this kind of the precursor to these types of path hopping manually when I first started out about 2.5 years ago. And I took a lot of this tradecraft and began to automate it using PowerShell, which our favorite term for it is Microsoft's post-exploitation language. So the entire project is one single file. It's self-contained. You don't have to install any additional modules. You don't have to drop anything to disk. We like to run PowerView very frequently through Cobalt Strike's Beacon. It's also pretty much completely implemented into the PowerShell Empire project, which I spoke on in this room last year about. So go back real quick. PowerView will collect all the data that BloodHound needs to build its attack graphs, and also has some really nice export functions and transformation functions built specifically for BloodHound, which I'll go over. And again, if you have elevated rights in a domain, meaning domain admin or server admin, you can get much more information, but you can get a huge amount of this information, even if you are a basic unprivileged domain user. So I'm going to go through the 3 different areas of information that Andy said were required for this attack graph design, and show you how PowerView collects that data under the hood. So the first thing is who's logged in where. We term this user hunting. So the main function for this in PowerView is invoke user hunter. It was one of the first ones that we ran. So there's a tool, netview.exe, written by Rob Fuller, that did something kind of similar at a more basic level in a compile C++ binary. Kind of took that, expanded upon it, and ran with it, and made it a much more flexible solution. So invoke user hunter will use 2 PowerView functions under the hood. It uses getNet session and getNet logged on and getNet logged on local. So getNet session uses the net session enum Windows API under the hood, and it does some really nice fancy trickery in PowerShell to access that without dropping any files to disk. GetNet logged on uses net workstation enum, and the logged on local is a new addition that uses remote registry if it's enabled. You can run these and get this information back without needing administrative rights in the remote system you're querying. There's also a stealth option. What this will do is it enumerates all the users in the entire domain, and it pulls out all the file paths, profile paths, and those particular type of Active Directory properties which might indicate a file server being used. So it gets a set of likely highly trafficked servers that most users touch, and then it just runs a getNet session against each one, and you can map back what users are logged on where, again with no elevated privileges. All right, now who can admin what? We have the first piece on who's located where. Now we need to know how to take those pieces and say who can actually triage this access. So this is one of the craziest things to me. Found this about 2.5 years ago. I think there wasn't a huge amount of information about it publicly, but we can enumerate the members of a local group on a remote system without needing administrative privileges on that system. I have no idea why this is allowed. We're super happy it's allowed, because otherwise this tool might not exist. But it kind of blows my mind. There's 2 ways to do this. The first is using, go back real quick. The first is using something called the WinNT service provider, which is a backwards compatibility type artifact in Windows. So this was a remnant of Windows NT domain deployments, or the net local group members Windows API call. With both these, you can just point them to a remote server, and it'll just spit back not just the user that's a part of the local administrators or any other local group you would like remote desktop. You can also get the SID, last logon time, password last change, and a huge amount of information that an unprivileged user has no right enumerating from these remote systems, but we're allowed to. In PowerView, if you want to execute this, you can do the getNet local group, one of the most common functions that will run. You can just do a computer name, an IP, NetBIOS name, and if you would like to use the API method instead of WinNT, the WinNT approach, which is the default, you can pass the optional -API flag. This is a bit of a new addition. A few months ago, I did a little bit of work with Sean Metcalf, and we realized that you can actually correlate group policy object information to determine the same type of data. So GPOs, group policy objects are just collections of settings that are applied to particular machines. One of these settings is who is the member of the local administrators group on the machine. It makes sense. It lets you do really easy, kind of mass management of this type of data in an enterprise. So if we correlate this data and do a little bit of trickery in the back end, and if you're interested in this, talk to me in the hallway. I love this stuff. But through just querying information on a domain controller, so we're not touching every single system like we did with the previous approach. We're only talking to a domain controller. We're pulling group policy object back, information back. We're linking that with where those policies are applied for sites and OUs. And we can get a really nice mapping of who can administer what machines with just communication to a domain controller, which is super normal. I can't imagine a way this would be detected. Maybe there's some vendor that can detect anomalous LDAP queries, but I haven't seen it yet. And it's much faster, but you don't get quite as much information. It's not quite as accurate. So the PowerView commandlet that does this is find GPO location. You can provide a username or a group name if you want to figure out what a specific person can administer in the domain. By default, it'll just dump all this data out. Pretty sweet. The last part is who's in what groups. This is the simplest one of all. So we want to enumerate all the groups. Just pull all the group names through LDAP, and then pull out the membership for each. In PowerView, we can do this super easily. GetNet group, pipe it to GetNet group member. If you're not familiar with PowerShell, this is the pipeline. It passes fully serialized objects between different commandlets or functions that you're running. So a lot of times by hand, we might do GetNet group with wildcards to say, okay, what groups have admin in them, and then let me enumerate all those users and things like that. If you do this by default, it'll just dump out all the nested group relationships in the entire domain. And that's it. Pretty simple. The least crazy of all of them. So PowerView has existed for a couple years. Again, we've been doing a lot of these approaches manually. BloodHound is going to include a slightly customized version of PowerView that has a couple extra functions in it. It's what we call the BloodHound ingester. So there's three commandlets, or three functions that are built into the BloodHound version. There's get-bloodhound data, and this will automate enumerating every machine in the domain and either by default touching every machine and gathering this information for completeness. There's also the stealth options, just hit DCs, just do sessions. There's tons of flexibility with how to run it. The second one is export BloodHound data, which will take all these objects that are returned from get BloodHound data. It'll JSONify them up and build the custom Cypher queries that are used by the backend solution for BloodHound. And it stuffs them into a REST API for ingestion. So the key here is we can do all this without touching disk if we want to, and we have the ability to bend our traffic back to the analysis server that we control. And also we have the option to just export all this stuff to a custom CSV schema that we developed. So if you can't, or if you don't have the bandwidth through an agent to actually send all this data back and don't want to wait, you can export it to a CSV, exfil that CSV somehow, and BloodHound will accept CSV ingestion as well.
Awesome. Okay, we're almost ready to show it to you, but we got a couple of other house cleaning items to share with you. So, BloodHound is the name of the product. A couple of facts about BloodHound. Let's go to the next slide. And the first item on here is that BloodHound is a web application that is built with Linkurious.js. Linkurious enabled us to quickly prototype and get the thing into a state where it was actually usable without becoming experts in like D3 or Sigma, which are the most widely used graph drawing libraries for JavaScript. Next, we stuff everything into an Electron binary. So it is platform independent. It doesn't require a web server to use. We're trying to make it as operationally friendly to use as possible. Next, it uses Neo4j as its graph database. We decided to go with Neo4j, and we also decided to go with Linkurious because they offered free and open source solutions that we could use to keep our tool free and open source. Finally, the information to go into the database is fed right now exclusively by the PowerShell ingester that Will was just talking about. All right, so I believe we have a video showing a demonstration of how easy it is to use this operationally for collecting information once you have your initial access into Active Directory.
Fast forward.
Here, I got it. You want to talk through this, Will?
Sure. Okay, so in this case, we're just showing it from a Windows system. You could do this over a remote route if you would like. We imported the PowerShell script straight off a disk, but we could also do this into memory if that's what we like to do. This is a slightly older version, so the syntax has changed a bit. We apologize, but we're going to have a ton of documentation, a wiki and stuff that shows exactly how to use it in the current state. So we're going to run get BloodHound data. I know the text is a bit small. Just get BloodHound data and passing the URI for the REST API ingestion endpoint. What's really nice with Neo4j is we also have a batch ingestion endpoint, so you're not having to do a call every single time. You can batch up like 1,000 queries at once and just stuff it into the backend database. Through here, we're doing verbose to show kind of like backend verbose debugging messages. It's doing the enumeration of all the sessions, all the computers, and you kind of see the little pieces there.
Yeah, so this very small little lab was 7 systems, and you can see that the collection finished in about 7 seconds. We did this on an op where our client had 200,000 workstations and servers. It took approximately 24 hours to collect the information needed to populate the graph database. Rohan is now going to show you the front end. So once you've actually populated the database with the info you need, which again you can do with the PowerShell ingester, now you're interfacing with the data through the BloodHound interface, which Rohan will show right now.
All right. So we do have all this prepackaged into an Electron container right now. Fun little story. About 2 weeks before this conference, my coworker here told me not to rewrite it into Electron, and I completely ignored him and did it anyway.
In general, I tried to give the advice that if you have a working product or a POC, maybe you might not want to do a ground up from scratch rewrite a week and a half before Vegas. But I'm happy with the end result, and I'm happy he did it. He put a huge amount of time into it.
Yeah, he's also not my supervisor. So. All right, so on the back end here, we actually have a Neo4j database running. This is actually data from a lab environment that Will very generously put together for us.
This is all semi-procedurally generated randomized data. This sample database is going to be distributed with the code on Saturday when it's released. So if you guys will have like a sample data set to play around with the tool.
So when you initially start up the BloodHound application, the first view you're presented with is any group that has the word domain admins in the name, as well as what users are part of that group or what groups are part of those groups. This is oftentimes one of the first things we try to enumerate, and we look at this data a lot. So it's really great to have this easily visible. So we're going to start by showing off some of the autocomplete here. Anything that is in the database, whether it's a computer, a user, or a group, you can autocomplete using the search bar here. So just to give you guys a user we're going to start with, we'll take this dude here, whose name is a little weird. If you click on any user, you're presented with a good bit of information over on the side over here. One of the first things you get is first-degree group membership. This is what groups the user is part of directly. You can also query unruled group membership. We're going to change the layout here so it's a little bit nicer. You can see what groups this user is part of by going through other groups.
Yeah, so what I would add to this is that what we were looking at before, where you just see the first-degree group memberships, that's what you would see if you did like net user blah / domain. That's the only results that you would see. So that's this first degree of separation, those first degree group memberships, and then you can see what effective group memberships this user gains through delegated groups.
Now, you can see that this user is a member of a group that's nested in like 5 other groups. And on assessments, that's the kind of thing that's actually pretty difficult to enumerate in a meaningful fashion. It's a lot of data that you have to keep track of. Were this user a member of the first degree local admins, which is direct admin to computer? If you do a net local group administrator on a computer, their name would show up. This would show up here. The next thing you can look at is group delegated local admin rights. So this is where the user has local admin because of his group membership. So you can see that this user is a member of the domain admins group, which is going to give him access to a lot of other things. Now, in the interest of performance, we actually do fold nodes into each other. So you'll see that there's an 87 next to this one. There's actually 87 computers hidden in this graph that you can't see.
But you can expand that data if you would like.
Which we will get to.
Oh, okay.
All right, the next thing we can calculate, and this is the really cool stuff that we really wrote BloodHound for, is derivative local admin rights. Now, derivative local admin rights will show you where a user has local admin to due to any form of path they can find, whether it's through a group or if it's grabbing a user from another system where that user is already logged in. So just as an example, this user is a member of the domain admins group, which gives him local admin to laptop 5. Laptop 5 has the user gshulk at internal.local logged in, and due to the fact that we can recover the credentials or steal the token of the logged in user, we can now impersonate gshulk and use that to move further throughout the domain.
Or into a different domain.
Yep. Now, were this user logged anywhere, you'd be able to query the sessions. One of the things that is obvious here is that these graphs get out of hand pretty quickly, provided the domain is large enough. So we added a very handy feature for you to be able to search through these graphs. So in this graph here, we're going to look for a group called research. And when you click on this, it'll zoom in on the graph and show you where that group is. Clicking on a group will give you a lot of extra information on the group as well. You can query who the direct members of that group are. You can query who the on-roll members of that group are. Once again, this query usually takes quite a bit of time to run if you're trying to recurse through groups. So having it all easily accessible in this fashion makes it a lot easier to work with. You can also see where this group is a direct admin to. So because these are all edge nodes, they've all been collapsed into here, we can right-click on a node and hit expand, and you'll get all these nodes very easily visible for you. A group can also have derivative local admin rights, the same as a user. So when we click on this, you'll see that through all the different sessions and admin rights, we can go further and further down through our domain. On this graph here, we have another node, SQL2. SQL2 is a computer. Computers also have their own set of data that's associated with them. You can say, who's a direct admin to this system? You can say, who are the unrolled admins? Despite the fact that there's only 6 explicit admins to this system, once you unroll group membership and members of those groups, you get 51 administrators. These are the kind of things that clients often don't know about just because as the domain continues to expand, groups become nested, and people forget what group does what. It is possible for a computer to be part of a group. This particular computer is not, nor is this computer in the local admins group of any computer, which we talked about as a very stealthy and interesting persistence mechanism. However, you can still calculate derivative local admin rights from a computer. It'll use the exact same methods through sessions, group membership, and admin rights to go further and further throughout the network. It is also possible for you to enumerate the sessions that are on a computer, same as just about any of the other things in PowerView. However, we're going to look at this one here. And you can see the attack paths get increasingly longer as you get more and more privileges. Finally, we're going to go on to one of the most useful features of BloodHound, which is pathfinding. By clicking on this button here, you can ask BloodHound to generate you a path from any node to any other node, provided the path exists. So just to give you guys a user here, we will go for our favorite group ever, which is domain admins. So as soon as you do this, BloodHound will query the database and try to find any paths that exist between these two nodes. Now this is a particularly interesting one for us. The user J. Druin, which is where we started, is the member of the external.local domain. As you move through this chain, you'll see that he's a member of a group, which gives an admin to a system, which has a session for another user, who's actually a member of a group in another domain. So we've now gone from the external.local domain to the internal.local domain. Jumping domain trust hops has always been a very interesting task that can be quite tedious. BloodHound has absolutely no issues finding the paths across domains, just through the data it already has. Following this path, you'll get a nested group membership here, which will give you admin to another system, which gives you the context of another user, which takes you finally to your target group.
Yeah, so what I would say is, as an operator, when you're looking at this graph, BloodHound is telling you exactly what you need to do to become a domain admin. So I need to start as this user on the left. I need to pivot to this computer here, where I need to steal this user's credential, And then I can either take this path or that path, pop one of the 3 computers that are 1 degree away from domain admins, steal a user password, and then because those users are part of the domain admins group, I've arrived at domain admin.
Just to show you guys another more complicated path, we'll take another user, Jay Nickel. Now, Jay Nickel is a member of a group here, which is a member of another group. And this group has admin rights to several other systems. Now, you can pick any of these systems, and the attack path will still be valid. Different users are logged onto these systems, and each of these paths takes you through a different group, but still ends up on the same system, which is desktop 11. Desktop 11 will give you the session for another user, and you can follow this chain all the way through more nested groups or through another computer, and your eventual result is a domain admins group. Now, another thing that we've been working on a lot is pre-built analytics queries. One of the things we like to do is find shortest paths to DA. This is a fantastic capability you can show to a client. When you click this button, you'll get a list of every group with domain admins. I can click on one of these and get a graph that's going to absolutely blow up my screen. So any of these external points here have valid paths to the domain admins.internal.local group. This is the kind of thing you can show a client and say, this is how many different paths I could have taken to get to the domain admins group. This is a far more comprehensive solution than finding a single attack path and showing it to a client.
Yeah, imagine the difference between delivering a report to your client saying, this is the one attack path that we identified and executed, and it took us 3 weeks to find, versus spending a day ingesting data and being able to tell them, these are all of the possible attack paths that existed in your environment during this period. We can identify hotspots in this graph, and we can do analysis saying, these are the reasons why these attack paths exist, and give them very fine-grained recommendations on what changes they need to make, whether it's user behavior or privilege that exists in the domain to eliminate most or eventually all of these attack paths.
We do have a few other built-in analytics queries here, user with most sessions, computer with most sessions. These help you identify users who are logging in the most or computers that are being logged into the most. We also do have the ability to map all the domain trusts in your domain. This is all queried as part of the get BloodHound data. I was talking about deliverables for clients. You can export a graph to either JSON or an image. The image will, something great you can throw in your outbrief, or you can give them JSON if they want to look at the raw data themselves. Now, we do actually have the ability, the get BloodHound data function will export to CSV, and you can do all that CSV ingestion directly through the BloodHound user interface. This is great if you want to take all the data offline, or you can't get a link from the client network back out to your database. You can just ingest it through here, and it's functionally exactly the same.
Cool.
That's about it first.
That's our demo. We're going to plug back into the deck. Awesome. So, DEF CON, Saturday, 1 p.m., track 1, is when we will be making BloodHound free and open source. So we have a couple of things we need to tweak. We're not quite ready to release it right now. At that time, go to bit.ly/getBloodHound. That'll redirect you to the GitHub repository where you can download BloodHound. We're going to have a wiki that will show you usage. We'll have the example database. We'll have the source. We'll also have precompiled binaries for you, or we'll have instructions on how you can build from source if you would like to do so. That's it. Thank you very much. On Twitter, you can find me @_Waldo with a 0. Rohan, you can find him at Captain Jesus. Will Schroeder, you can find him at @HarmJoy. Thank you very much. I think we have time for questions.
Yeah, we have 15 minutes for questions.
We have 15 minutes for questions. Anybody have a question? Yes? Oh, okay.
Are there any tools commercially available for clients to do this type of analysis?
The question was, are there any commercial tools available already for clients to do this kind of analysis? The answer to that is yes and no. Yes, in that Microsoft actually built something very, very similar to this in 2009, which they called Heat Ray. There was research done by Alice Zhang and John Dunnigan at Microsoft Security Research Center. They built something called Heat Ray that, like I said, operated on identity snowball attacks. However, it was never made public, and I don't know why. There may be other commercial solutions. If there are, I don't know about them.
And there's a really cool white paper on the heat ray approach that was released if you just search Microsoft heat ray.
Yeah, that blog post, attackers think in graphs, defenders think in lists. Go to that blog post. At the very bottom, go to the resources, and you can find a direct link to the PDF, which is that white paper of that research. I highly recommend reading it.
Also, we had two tips for people who ask questions. So, whoever asks this question, if you want a book or a screwdriver.
There was a question in the back. Yeah. Oh yeah, we also have stickers if you would like a cool sticker to put on your laptop.
So first, congratulations for the great tool.
Thank you.
And great talk.
Thank you.
In terms of the queries, it is possible to import and export them.
The queries.
Exactly. So let's say that I have a type of a path that I want to export.
Yes.
And use in another time.
Yes, you can. So Rohan showed the attack paths going from one user to the domain admins, and I believe your question is if you can export that graph so you can use it in a different tool. No.
Let's say that if I can follow certain types of nodes to reach something, if it is possible for me to export that logic. So let's say if I can found this type of group and then the other one, I will reach DA. So if I can export that type of query and then to use another database.
Yes, so the query language that we're using in BloodHound is the Neo4j query language, which is called Cypher. We are sharing what those queries are. If that doesn't quite answer your question, maybe we can talk offline about it.
Okay, great.
Okay.
Thank you.
Two questions. The first one, did you have a path of least resistance so you kind of could show the easiest path? And the second question is, how about updating? So if you had the big client where it took 24 hours, you want to do it later, how does that work?
All right, so his first question was, remind me your first question, I'm sorry.
Path of least resistance.
Path of least resistance. So by default, BloodHound is running a query in Cypher called all shortest paths. This is going to typically run Dijkstra's algorithm to identify the shortest path from one node to the other. What we are planning to implement, which we do not have right now, is something called conditional pathfinding. So say, for example, I don't want necessarily the shortest path, but I want a path that meets certain criteria based on maybe scope or rules of engagement. Let's say, for example, that I don't want to touch any Windows 2012 systems. So show me a path from this node to the other, and don't include any Windows 2012 systems. Or I can say I explicitly want to include a certain system in that attack path. Your second question was updating. I'm going to let Rohan answer that updating the interface is very simple through Electron. It's going to be similar to Chrome. You close it, you open it, but that wasn't your question. Your question was updating the information in the database, right? Okay. So that brings into the difference between what is kind of static information and what's dynamic. In Active Directory, privilege and group membership information is going to be relatively static. It's not going to change all that much day to day. User logon information is going to be much more dynamic. So you can add information to the database, and it will not clobber information that's currently in there. So you're going to be adding more user session information every time you do this. Something that we want to add is temporal information to these edges. So say, for example, on August 9th, I did a collection, and I knew this user was logged on here. But then by the time August 12th rolls around, that session may not be available. So something we are planning on implementing is again with conditional pathfinding. Show me a path that doesn't rely on a relationship that is outdated, which I can define myself. So show me a path that is likely to be still valid by showing me something that is from today or something that is from yesterday. What that will also do is it'll equip incident handlers or forensic staff to look at a system that may have been compromised and say, this compromise happened on March 21st. I want to go into my BloodHound data and I want to say, show me what this database looked like on March 21st, and show me not only the system that was compromised, show me all of the possible other systems that the attacker could have possibly spread to, so that I can increase and hone in on my forensic scope.
Just to add a small little thing to that, we've actually we've used this tool on a few assessments at this point, and in most cases, if a user is logged into a box or has a session, they're usually going to be logging back into that box again. Users and other things on the domain tend to keep reusing the same Active Directory objects. So from our experience, the session data, despite the fact that it can be outdated, has never actually yielded a path that was not valid, even a day, maybe 2 or 3 later. So,
Any other questions? If you want to chat with us, we'll be out in the main room for a little bit.
Yeah, we've also got little cool stickers. If you would like one, come up here and grab one. Again, thank you very much.